What if the greatest wilderness in the universe is not beyond the stars, but directly beneath your feet? We spend fortunes trying to decode distant galaxies, yet the ground under a suburban driveway, a cornfield, a cemetery, or a city sidewalk hides a vertical world we have barely begun to understand. Humanity's deepest borehole, the Kola Superdeep in Russia, reached 12,262 meters, and even that is less than 0.2% of the way to Earth's center. By comparison, Challenger Deep in the Mariana Trench reaches about 10,935 meters below sea level, which means our deepest hole into solid rock only barely exceeds the deepest known point in the ocean. That is the scale of our ignorance. We live on a shell so thin, so fragile, that geologists often compare it to the skin of an apple or the shell of an egg. And yet everything we call civilization, war, empire, farming, burial, transport, memory takes place on that skin, while below it pressure rises, heat intensifies, and familiar matter begins to behave in unfamiliar ways. Tonight, we are not going down to chase fantasy. We are going down to confront a more disturbing idea, that the planet supporting our lives is mostly a realm we cannot enter, cannot see, and may never truly master. The descent begins not in some dramatic abyss, but in the first inches of ordinary soil. Americans often imagine the ground as static, a brown layer that simply holds up roads and roots, but the upper soil horizon is closer to a crowded underground city than a dead surface. Within the top foot, worms, insects, fungi, microbes, and burrowing animals are constantly breaking down organic matter, moving nutrients, opening tiny air channels, and reshaping the chemistry that makes plant life possible. This is where the hidden economy of land begins. A lawn may look quiet from above, yet below it millions of organisms are building and dismantling habitats in darkness. Go a little deeper, and the emotional meaning of the ground changes. Across cultures, only a few feet down is where people have entrusted the dead to the earth, hoping that soil might do what memory cannot preserve some trace against time. In the Valley of the Kings, the tomb of Tutankhamun was discovered beneath a staircase cut into rock and sealed for more than 3,000 years, a reminder that dry, oxygen-poor underground spaces can preserve astonishing detail far longer than the world above. Long before rock pressure becomes lethal, the subsurface is already doing something profound. It is storing life, grief, and history in silence. At depths measured not in miles but in meters, the underground becomes political. In Vietnam, the Chu Chi Tunnel network grew into a vast wartime landscape, stretching roughly 250 kilometers at its peak and containing hospitals, storage areas, kitchens, command posts, and trap systems beneath a surface controlled by superior firepower. The lesson was brutal and simple. Whoever controls the visible world does not always control the real battlefield. The same logic appears again and again through history. Underground space became shelter from bombardment, from occupation, from surveillance, from weather, from the state, and sometimes for the state itself. In the 20th century, governments around the world designed hardened bunkers below ground because soil and rock absorb blast waves, isolate sound, and shield populations or command structures more effectively than exposed concrete ever could. But the underground is not only human refuge, it is also biological strategy. Some of the deepest roots ever recorded, those of a wild fig associated with South Africa's Echo Caves, have been calculated to reach about 120 meters, probing fractures in rock in search of water where no sunlight penetrates. Even before we reach industrial depth, one truth becomes unavoidable. To go underground is to enter a zone where survival favors patience, concealment, and systems invisible from the surface. By around 20 meters down, cities begin to acquire a second body. Paris is one of the clearest examples. The official catacomb site places the ossuary roughly 20 meters below street level, inside former limestone quarries, later turned into a vast underground resting place after the city's cemeteries became dangerously overcrowded. Today, the public route is only a small curated section, yet the broader quarry network beneath Paris extends for hundreds of kilometers, and the remains of more than 6 million people are associated with this subterranean system. That is not just a burial site, it is an inverted city of memory under the living one. Sound from the streets above largely disappears. Daylight is gone. Orientation begins to fail. What remains is architecture stripped to mass, void, and bone. This is where the underground stops feeling like beneath and starts feeling like an alternate version of the world above. Streets have echoes. Walls have histories. Empty quarry corridors become civic infrastructure, tourist sites, illegal routes, and monuments to public health crisis all at once. The earth here is no longer merely geology. It becomes urban storage for everything the surface could not safely contain. And that pattern continues into the modern age. Because once humans learn that underground space can solve a crisis, they keep returning to it. That return is one reason the underground in the 21st century is no longer just about death or defense. It is increasingly about continuity. In London, commercial underground farming has operated in repurposed deep shelters about 33 meters below the city, using LED lighting, hydroponic systems, and highly controlled environments to grow greens with minimal exposure to weather and pests. Similar experiments and commercial operations in Europe and Asia show why the idea is attractive. Underground agriculture can reduce land pressure, shorten delivery chains, and disconnect food production from drought, frost, and polluted surface runoff. This matters in a century defined by climate volatility. At roughly the same scale of depth, transport systems also begin to reveal how much modern society depends on invisible engineering. For decades, Kiev's Arsenalna station, about 105.5 meters deep, was famous as the deepest metro station in the world, though by 2026, newer stations in China are often listed deeper. The symbolic point still stands. Cities survive not only through what rises into skylines, but through what descends beneath them. Escalators through bedrock, service corridors behind retaining walls, ventilation shafts, power lines, water conduits, drainage systems. From the street, a city looks horizontal. From an engineer's perspective, it is vertical. And the deeper that verticality extends, the more civilization begins to resemble an organism with buried organs no casual observer ever sees. Farther down, the underground stops being metaphorical and becomes mechanical. Under rivers, under straits, under mountain pressure, human construction enters a contest with seepage, collapse, corrosion, and time. The Congo River offers a natural preview of that contest. Parts of it reach depths of about 220 meters, making it the deepest recorded river on Earth, so deep in places that sunlight does not effectively penetrate to the bottom. That single fact rewrites the familiar image of a river as shallow flow. In the Congo, a river can behave more like a submerged canyon. Engineers face related extremes in the Seikon Tunnel in Japan, whose track level lies about 100 meters below the seabed and roughly 240 meters below sea level as it passes beneath the Tsugaru Strait. When people move through such infrastructure, they are often unaware of the mass above them, water, rock, and the accumulated force of a planet pressing downward at all times. This is one of the strangest truths about modern life. Some of humanity's most ordinary acts, like commuting, rely on extraordinary confidence in hidden spaces. We trust reinforced concrete, pump systems, sensors, steel linings, geological surveys, and maintenance crews we will never meet. The surface teaches us to think in terms of horizons. The underground teaches us to think in terms of containment. Then comes the threshold where the earth starts pushing back. Deep mines are not simply holes made larger. They are artificial environments carved into rock that is hot, stressed, fractured, and trying to close itself around the intrusion. In South Africa, Empaneng remains one of the deepest operating gold mines on Earth, extending more than 4 kilometers below the surface. Rock temperatures in the deepest working areas have been reported around 66 degrees Celsius, which is far beyond what humans can tolerate for long without powerful cooling systems. The descent itself can take more than an hour. Air has to be chilled, water has to be managed. Excavated spaces must be supported before the surrounding rock shifts or bursts. At that depth, mining becomes a daily negotiation with thermodynamics and geology. What makes the scene even more unsettling is that this extreme environment is not sterile. Researchers have found microbial life deep within Earth's crust, including organisms living in water-filled fractures and surviving without sunlight, drawing energy from chemical reactions involving surrounding rock. That discovery changes the emotional meaning of depth. We are used to thinking of life as something that depends on sunlight, leaves, and air. But the deep subsurface suggests that life can persist in darkness, isolation, and chemistry alone. The underground is not only a place where human bodies struggle, it is also a place where biology quietly rewrites our assumptions. Yet even the deepest mine is shallow compared with the great scientific gamble of the 20th century, drilling for knowledge rather than ore. On the Kola Peninsula, Soviet scientists began the Kola Superdeep Borehole to learn what the continental crust was really like at extreme depth. By 1989, the project reached 12,262 meters, still the deepest artificial point humans have ever created in Earth's crust. But what makes Kola so important is not the number alone. It is what the borehole did to geological assumptions. Temperatures rose to about 180 degrees Celsius, far hotter than expected, making deeper progress increasingly impractical. Rocks thought to mark a transition from granite to basalt did not behave as textbooks had suggested. Fractured zones contained hot, mineralized water where many scientists had not expected free water to exist. Microscopic fossils of ancient marine plankton were reported from rocks several kilometers down, preserved in surprising conditions. And one of the most famous public myths about the borehole that scientists recorded the screams of the damned from below was just that, a myth, unsupported by the actual scientific record. The real story is more impressive than the legend. Kola showed that when we finally managed to punch a narrow instrument into the deep crust, the planet answered not with horror movie drama, but with a more unsettling message. Your models are incomplete. Once we leave the range of direct drilling, almost everything we know about Earth's interior comes from indirect evidence, especially seismic waves generated by earthquakes. Those waves move through the planet the way medical imaging moves through the human body, revealing boundaries, densities, and changes in state from their speed and behavior. What they show is astonishing. The crust, the zone that contains every ocean, mountain range, battlefield, cemetery, farm, and city we have ever known, is vanishingly thin relative to the planet as a whole. Under oceans, it may be only about 5 to 7 kilometers thick, while beneath continents, it averages roughly 35 kilometers and can be much thicker beneath major mountain belts. Beneath that lies the mantle, extending to around 2,900 kilometers deep and making up about 84% of Earth's volume. It is not a simple ocean of liquid rock, but a mostly solid silicate layer that can nevertheless flow over geological time under immense pressure and heat. This slow movement drives convection, and convection drives plate tectonics, volcanism, and much of the long-term thermal behavior of the planet. In other words, the apparently stable world above is riding on a mobile foundation. Continents are not anchored the way common sense suggests. They are passengers on a moving shell over a deep interior that never truly rests. Below the mantle, at roughly 2,900 kilometers down, the Earth undergoes one of its most important transitions. The outer core begins, a vast metallic layer composed primarily of molten iron and nickel. This fluid outer core is not just another hot region. It is the source of most of Earth's magnetic field. NOAA notes that more than 90% of the geomagnetic field is generated by processes in the outer core, where conductive liquid metal moves under the influence of heat flow and planetary rotation. That invisible magnetic shield is easy to ignore because it is always there. But without it, solar radiation would interact very differently with our atmosphere and the technological systems that modern civilization depends upon. The outer core turns depth into protection. The violence of molten metal motion, thousands of kilometers below our feet, is one reason compass needles work. Satellites must account for magnetic variation, and life on the surface has had a more stable atmospheric home than a world like Mars. The irony is almost too large to grasp. One of the gentlest conditions of ordinary life, the ability to stand under an open sky without being stripped bare by radiation, depends on a hidden engine of liquid metal in permanent motion far below any human reach. Earth's safety is not produced at the surface. It is manufactured in the abyss. And then, deeper still, comes the part that sounds impossible even when it is true. At about 5,150 kilometers below the surface, Earth's inner core begins. Its radius is about 1,221 kilometers, and despite temperatures comparable to the surface of the Sun, often estimated around 5,000 to 6,000 degrees Celsius, it remains solid, not because it is cool, but because the surrounding pressure is so immense that atoms are forced into a tightly packed structure. Here, matter obeys rules far removed from everyday intuition. For years, some researchers argued that the inner core rotates slightly faster than the rest of the planet, a phenomenon often called superrotation. More recent work, including a 2024 study highlighted by Cornell and other outlets, suggests the inner core may have slowed relative to Earth's surface, showing that this is still an active scientific debate rather than a settled cartoon fact. What is less disputed is that the core continues to matter profoundly to the planet's long-term evolution. As Earth cools, crystallization, at the boundary between the liquid outer core and solid inner core, releases energy that helps power the geodynamo. So even the hard center of the world is not dead mass. It is part of a system still changing. The deepest place in Earth is not a final stone endpoint. It is an active participant in the story of the whole planet. So what did this descent really reveal? Not just that the Earth is deep, hot, and difficult to penetrate. We already suspected that. What it reveals is that nearly everything that makes surface life possible depends on realms we cannot visit directly. Soil ecosystems feed forests and farms. Buried chambers preserve empires and grief. Tunnels reshape war. Catacombs mirror cities. Underground farms hint at how food systems may adapt to an unstable climate. Deep mines expose the limits of human endurance. Boreholes humble our theories. The mantle moves continents. The outer core generates the shield that protects our world. And at the very center, a solid iron core endures under conditions so extreme that human language can describe them more easily than human technology can ever touch them. Even if we somehow engineered a machine to survive the heat, the pressure, and the closing rock, the journey would still be defeated by scale. Earth's center lies about 6,371 kilometers from the surface. We have not come close. We have barely scratched the shell. That is the unsettling beauty of this planet. The ground beneath us is not a floor. It is a lid, and under that lid is the long, unfinished story of how Earth works, how it remembers, and how it keeps us alive without asking for our attention. If this kind of hidden reality is what pulls you in, stay with what the Earth hid. There is something humbling in realizing that the greatest mystery in our lives may not be above us at all, but beneath every step we take.